Hello everyone, let's take a look at another problem. Prove the statement using the epsilon delta definition of a limit. The limit as x approaches negative 1.5 of 9 minus 4x squared divided by 3 plus 2x is equal to 6. Okay. So this is a limit that I guess this has to be a limit in the form 0 over 0, right? If I substitute negative 1.5 into here, I get 0. And so for this limit to be anything finite, the numerator also has to be 0, but I don't really want to work out the details. And so in order to prove this using the precise definition of a limit, right, we'll have to find, for any epsilon, we'll have to find a value of delta, which makes the whole series of inequalities work. One thing I'm thinking here, though, is because it's a 0 over 0 form, the numerator can probably be factored to cancel with something in the denominator, and you can actually see that immediately by looking at what we have written. So what I'll do is I'll start by writing out exactly the epsilon delta statement that we need to prove. Then I'll do a little bit of rough work with the factorizations and cancellations and all that to see if I can intelligently choose the relationship between delta and epsilon, and then I'm going to put it all together, given that choice that I figure out, I'm going to put together the sequence of steps to show the proof for this limit. Okay, so now that I see this is the thing we're really trying to prove, at some point in my final argument, this is something I'll have to keep in mind, I'm going to want to do a cancellation of things here after I factor the numerator, and that cancellation will be completely valid because this denominator is never actually equal to 0, and it's never actually equal to 0 because of this part of the inequality. Okay, after going through some manipulations of things, I did the factorization like I said. I get a cancellation. Then when I subtract negative 6 from both sides, I get some expression here. Take an absolute value. So now the absolute value of this whole thing, that is the quantity that we're trying to bound by epsilon here. And I can show that this is equal to 2 times x plus 1.5. But x plus 1.5 is exactly the quantity that we have control over by choosing delta. So if I choose delta to be equal to epsilon over 2, this thing becomes epsilon. So let me go through the entire argument now to prove this limit. All right, and there's the sequence of inequalities that gives us exactly what we want. Well, inequalities and manipulations. I basically started with the thing that we're trying to bound by epsilon, did a whole bunch of manipulations, and ended up writing it in terms of the thing that we are able to control directly by delta. And then by using the choice of delta that I made earlier, that delta is equal to epsilon over 2, I have that this whole thing is less than epsilon. Yeah, fairly straightforward overall, but if I have any more to say about this one, I'll put it down in the description. Thanks for watching.